Lesson 5-1, solving one-step inequalities. So inequalities are those symbols that you're comparing, greater than, less than, greater than or equal to, less than or equal to, and the one that we don't think too often about is does not equal to. And so we're going to be looking at inequalities where you can graph them, and if you graph them, there's going to be different kinds of circles, such as you have an open circle here, or you have a filled-in circle based on the symbol, comparison symbol that you're using. So let's first off look at what is an inequality. An inequality is just a mathematical sentence that contains the symbol less than, greater than, less than or equal to, greater than, or does not equal to. An inequality compares the value of two numbers or expressions using these symbols. Now, some students struggle with determining is it less than or greater than. They forget how to read them. So if you think of your left hand and form this symbol with your left hand, that's the less than symbol. So think of left, less than. And then when you have your right hand and put your right hand in front of you and form this with your hand, that's the greater than symbol, but that's the bigger number. The bigger number is on your right hand. So when you see that, that means the greater than symbol. So the addition property of inequality. We've gone through addition property of equality. This means whatever you do on one side, you add the same number on the other side, they're still equal. The same thing with inequalities. If the same number is added to each side of a true inequality, then the result of the inequality is also true. So if A is greater than B, then I can add C to both sides, and A plus C would still be greater than B plus C. Just like subtraction, we would do the same thing. If A is greater than B and I subtract C from both sides, A minus C is still going to be greater than B minus C. So when we solve these inequalities, the solution set can be written using set pillar notation and graphed on a number line. So again, set pillar notation means you have the brackets or the braces here, x such that wherever the variable is, x is less than 4. That would be an example of set pillar notation. So our first example, solve inequality. So x minus 10 is less than 15. We just treat this just like any other equation. So to get x by itself, I add 10, always the opposite of what they're doing, and I have x is less than 25. Letter B, x plus 24 is greater than or equal to 61. The opposite of adding 24 is subtracting 24. And I have x is greater than or equal to 61 minus 24. This would give us 37. So it's 37 plus 24 would give us 61. So our answer would be x is greater than or equal to 37. Next, here we're going to solve this one. Now I need to get x by itself, so I'm going to subtract 13 on both sides. And now I'm left with 75 is less than x, or we can write it as x is greater than 75. Both of those mean the same thing. I typically write it with the variable first on the left-hand side, and then I would read it x is greater than 75. Letter B, I would add 9 to both sides, and now I would have b is less than or equal to 25. A couple more examples. X minus 7 is less than or equal to 15. I add 7 to both sides, and I have x is less than or equal to 22. And letter B, I subtract 22 on both sides, and I would have z is less than negative 28. Example 2, subtract to solve the inequality with variables on each side. So again, we need to get all the variables to one side. I typically put the variables on the left-hand side, but you can put it on the right-hand side. It's up to you which direction you want to do it. The only difference, or the one caution I would say is when you make the coefficient in front of the variable negative, you're going to have to do an extra step. And we'll get to that a little bit later. So for this one, I want to keep my y's positive. So since 10y is bigger than 9y. I'm going to bring my 9y to the left-hand side, or the right-hand side. I'm going to subtract 9y on both sides. And now I have 3 is greater than or equal to 1y. Or I could just rewrite this as y is less than or equal to 3. They mean the same thing. I could also just flip the whole thing before I solved it. Next, solve -5 plus a is less than 2a. So if I subtract a on both sides, I'm now left with -5 is less than a. Or we can write it as a is greater than -5. Example 3, use word problem. So it says wireless contract allows you to use at most 5 gigabytes of data per month. At this point, Hassan has used 3.7 gigabytes of data. How many gigabytes of data can Hassan use during the rest of the month without exceeding the maximum allowance? So right now, he has used 3.7 gigabytes of data. Plus, we don't know how many more gigabytes of data. So I'm going to use a variable here. I'm going to use x. And it says in here, use at most. That means I cannot go more than. So it has to be less than or equal to 5. So 5 is the maximum. To solve for this, I just subtract 3.7 on both sides. And I would have x is less than, this would be 5.0, borrow, that would give us 3, 1.3. So x has to be less than 1.3 gigabytes. Next, the website traffic. Drew One's blog received 3 or 20 views after his most recent post, bringing his total views up to more than 1,000. How many views did Drew One's blog have before his most recent post? Write an inequality, represent the situation, then solve the inequality. So he received 320 views after his most recent posting, bringing his total views up to more than 1,000. So more than 1,000 means greater than 1,000. So he gained 320 before the most recent. So I put V here. We don't know how much he had. To find that, I'm just going to subtract 320. And we would have V is greater than 1,000 minus 320. So this would give us 8. So 680. So he had more than 680 views before his most recent post. The second part of our lesson is dealing with multiplication and division. So when you are multiplying or you're dividing by a positive number, the symbol stays the same. But if you divide or multiply by a negative number on both sides, then you have to remember to flip the symbol. So in these bottom two boxes, you have to remember to flip the symbol when you multiply or divide by a negative number. So our first example, Alyssa has read approximately 1/4 of the novel. If she has read at least 112 pages, how many pages are there in the novel? So 1/4 of the novel, that would be 1/4 of means multiplication, and I'm going to use n for novel. If she has read at least, that means it cannot be smaller than 112. So at least 112. To get n by itself, I multiply by the reciprocal, so I multiply by 4. This will give us n is greater than or equal to 448 pages. Now I don't have to flip anything, a symbol, just because this was all with positive numbers. Next example, the outdoor club needs to save at least. So at least means greater than or equal to $6,500 for an annual trip. Their goal is to raise $250 every week for X weeks through private ski and snowboard lessons. For at least how many weeks will the club need to raise funds before they can afford to pay for the trip. Write an inequality to represent the situation, and then solve the inequality. So they has to raise $250 per week, which means every week 250. So that's 250 times X has to be at least $6,500 they need to raise. So that'd be greater than or equal to 650. Now to get X by itself, I just divide by 250, and I would have X is greater than or equal to 26 weeks. Solve each inequality, then graph the solution on number line. So here we have negative 2/5 X is less than or equal to 11. So to get rid of the X, or to get X by itself, I have to multiply by the reciprocal, which will be negative 5 halves. Whatever I do on one side, I have to do on the other. So this will give us 1x. 11 times 5 is 55 over negative 2. Now, because I multiplied by a negative number, I have to flip the symbol. So now it's going to be greater than or equal to negative 55 halves. Now, one thing that you might want to check is, why did we have to flip the symbol? So if I give a number, let's say if I didn't flip it, if I said it was X had to be less than or equal to a negative 55 halves, if I choose a number that was less than negative 55 halves, so negative 55 halves, so negative 55 divided by 2 gives us negative 27 halves. So if I chose negative 30, and so I have negative 2/5 times negative 30, is that going to be less than or equal to 11? So I can, negative 2 times negative 30 is 60. 60 divided by 5 is 12. Is 12 less than or equal to 11? No, that is not correct. So that's why we had to flip the symbol. So now if we choose a number greater than 27.5, so that would be like 0 is bigger than negative 27.5. If I put negative 2/5 times 0, is that going to be less than or equal to 11? Anything times 0 is 0. 0 is less than or equal to 11. Therefore, I know that this is the correct symbol. Number line, I just need to have 27.5 or negative 27.5. Because I have the equal to symbol, it can equal negative 27 fifths. So I have a filled in circle. Greater than means to the right. Bigger numbers always go to the right. Next example, 20x is less than 4. The opposite of multiplying by 20 is divided by 20. And I have x is less than 1/5. I did not flip the symbol because I'm not dividing by a negative number. So on a number line, I have 1/5 here. It's just plain less than, so it's an open circle. Less than means to the left. Next, negative 3/7 x is greater than 24. Need to multiply by negative 7/3. So the negative as our reciprocal of that, so negative 7/3 on both sides. This will leave us with x. Because I multiplied by a negative number, I flip the symbol, so now it's less than. 24 divided by 3 is 8. 8 times negative 7 is negative 56. So on my number line, I have negative 56 here. I have an open circle because it cannot equal 56, negative 56. Less than means to the left. And if I want to double check that, pick a number less than 56. I could choose, I'll just choose negative 70 because I know I can divide 7 equally. So negative 7 or negative 3 over 7 times negative 70 has to be greater than 24. So I can divide a 7 here, divide a 7 here, and get negative 10. Negative 3 times negative 10 is 30. 30 is greater than 24. So I know that my answer is correct. Next, multiply by 4. So divide by 4 to get b by itself. B would be less than 9. On a number line, as just a less than, so open circle, less than means to the left. And our last question, solving inequality by multiplying and dividing. So the opposite of multiplying by 7 is dividing by 7. And I have x is now greater than 161 divided by 7. Negative 161 divided by 7 gives us a negative 23. Now some might wonder, why didn't I flip the symbol here? I didn't flip the symbol here because I was not dividing by a negative number. The number I'm dividing by is a positive 7. That's why this one is just greater than negative 23. That is our lesson on one-step inequalities.